While it's definitely useful to be able to find the margin of error for a given poll, it's probably more useful in practice to be able to find the number of people that have to be polled to get a margin of error that you find acceptable, and that's what this question is about. A survey is described for us in which 11% of Americans say that they lack health insurance. So that's going to be our p hat. That's the proportion of people giving the response that we're interested in a poll, and that is 0.11 because it's a percentage in decimal form. The question is how many people need to be surveyed, so we're looking for n in our formula, and we're told that we want a margin of error of 2%. Well, in our notation, that means we want the margin of error to be 0.02, which is the decimal equivalent of 2%. So now we're going to use our margin of error formula, which I will remind you is 2 times square root of p hat times 1 minus p hat over n. Now what we know here is we know the margin of error we're shooting for is 0.02. We know that p hat is 0.11, which makes 1 minus p hat 0.89. We don't know n. Now our job is to solve this equation for n. What we're going to want to do is square both sides to eliminate the root, but first we want to get rid of the 2, so we'll divide both sides by 2, and that's going to give us 0.01 on the left, and now on the right we'll just have the root. Now we'll square both sides to eliminate the root. On the left side, we get the square of 0.01, which is 0.0001. And on the right side, the root's gone, which was the point of squaring in the first place, so that's good. Now we'll multiply both sides by n to get it out of the denominator. And finally, we'll divide both sides by 0.0001. And this works out to be 979, which tells us for this particular survey, in order to have a 2% margin of error, meaning that we can be 95% confident that the actual value of Americans without health insurance is within 2% of 11%, we would need to poll 979 people.